Hi, hello everyone. Happy morning to all. Welcome back to the channel. In today's video, we are beginning with some exciting problem on electromagnetic induction. Here, I am going to explain about the key concepts on solving the problem step-by-step manner on magnetic flux, Faraday's law, Lenz law, and AC generator. Here I'm just going to give an ideology on the essential on this essential topics, whether you are a student or a curious mind to know about the problem. This problem will help you in deeper to understand it. Make sure that to hit the like buttons and subscribe for more problems relevant to the presentation and keep on updated. We'll go for the problems now. The first problem here is a coil of 100 turns and area 5 square centimeter. See here, this is 5 square centimeter is placed in a magnetic field that is 0.2 Tesla. The normal to the plane of a coil makes an angle theta with the direction of the magnetic field. Now, the magnetic flux linked with the coil is, so what they are asking here is magnetic flux linked with the coil. Now see here, what are the data has been given? 100 turns. 100 turns means they have given about n value 5 square centimeter. We need to convert this one in meter. So here area has been given, magnetic field value also given here, and the angle theta value also given. See from this one, see what we are going to find out here is magnetic flux linked with the coil. Now I just mentioned here. So magnetic flux linked with the coil here is pi is equal to n dA cos theta. Now this one n values what they have given here is n is 100 turns and B value here is 0.2 Tesla, and area what they have given here is 5 square centimeter, that is 5 into 10 power minus 2 centimeter square. In this case that will become whole square, that is 10 power minus 4 into cos of, I just mentioned here, cos 60 degree. Now this one here is, see, zero point 0.2 into 100 here is 20 here, 20 into 5 into 10 power minus 4, and cos 60 here is 1 by 2. Now you just cancel here. So what you are going to have here is, so this one will be cancelled again. Say this will cancel for 10 times, and this one again you just make it cancel here, 50 into 10 power minus 4. Flux here is, we can mention in Weber, 15 to 10 power minus 4 or 5 into 10 power minus 3 Weber. So answer in this case, problem here is a magnetic field in a certain region is given by, so they are given magnetic field B is equal to 40 I minus 18 K. This is they have given in Gauss. Remember here B is in Gauss. Usually magnetic field should be in Tesla. See for this one what I am going to do, see I just mentioned here Gauss to Tesla here is, see this one Gauss will be equal to 10 to the power minus 4 Tesla. Remember this one. How much flux passes through a 5.4 centimeter area loop if the loop lies in XY plane? So they have mentioned as XY plane. So what I'm going to do, again I just draw, this is about y-axis here, and this one I just mentioned as x-axis, and see here this is z-axis. So this is xy plane. Xy means this is x side plane here, and this is y plane here. So this one here is xy plane. So this is x and this is y. Along this direction, that is about z direction, the magnetic field is going over here. See for this one, B vector here is, they have given B vector is equal to this one, and area I just mentioned as A vector will be equal to 5 into centimeter square, I just mentioned as 10 power minus 4 meter square. This is along K axis. So this is along XY plane. So K vector means this is XY plane, right? Now, from this one, what they are asking here is how much flux passes through. Flux in this case, pi is equal to B dot A, B vector dot A vector here. So B value here is 40 I minus 18K. So this is in Gauss. You are going to convert this one in Tesla. So according to 1 Gauss here is 10 power minus 4 Tesla here, into area here is 5 into 10 power minus 4. So from this one, I dot this one here is K vector. So I just mentioned as K vector here. I dot K here is 0 here, and k dot k here is 1. So from here what I'm mentioning here is 18 into 5. There are 10 power minus 4 is there, and this side for 5 also 10 power minus 4 is there. So what I'm going to mention here is minus 90 into 10 power minus 8. So pi in this case flux means we are mentioning as Weber, or else we can mention this one minus 900 into 10 power minus 9 Weber here. So answer in this case here is minus 900 nano Weber. So answer in this case, yeah, a bar magnet M is allowed to fall towards a fixed conducting ring. See here, this is the bar magnet which is allowed to fall in the fixed conducting ring if G is the acceleration due to gravity. If G is the acceleration due to gravity, and V is velocity of the magnet at t equal to 2 seconds. At t equal to 2 seconds, V is the velocity and S is the distance traveled by it the same time. At the same time, even t equal to 2 seconds. From this one, see here what they have mentioned: if velocity which is greater than or less than of gravity acceleration due to gravity, similar like distance. See from this one, from here what you are going to mention here is what you mean by Lenz law. See, for this one let me tell you, whenever the lens is moving uh, towards the conductor, fixed conductor here. So this one, the changing magnetic flux, this one here is the changing magnetic flux around this one. I can mention over here. See this one, from this case, see from a north pole to south pole, if the magnetic flux is keep on changing over like this. Now I just mentioned this one, whenever this magnet is approaching towards the ring. So here the flux will be keep on changing over here, like this will be keep on changing over. The changing magnetic flux will be produce the current around this coil. According to Lenz law, around this coil the current will be produced over here. Now this changing a current, it try to opposes the motion of magnetic bar magnet towards the coil. So what is going to happen here is, whenever the magnet is approaches over here, if there is no current means it will be moving with the same speed and it will cross over like this. But because of the changing magnetic flux and because of the Lenz law, what's going to happen here is, this changing magnetic flux is linked the current to the coil. This changing the current in the coil that opposes the changes of the magnetic flux. So that, say for example, if it is moving with the 10 meter per second velocity, whenever it is going to approach towards the coil, that velocity will decrease. Simple concept, that's all. That is the matter over here. According to this, I just mentioned this one. For example, velocity, how you can mention here, velocity based on the motion here is v equal to u plus at. U is about initial velocity here, u is equal to 0. So v is equal to, here a here is acceleration, if which is acceleration, if it is if acceleration is greater than g. So that what happen here is, without any disturbance, so the magnet will be passing the coil. But because of the Lenz law, what is happening here is, your acceleration of the bar magnet, which should be less than the acceleration due to gravity. So that what I'm going to mention here is 0 plus a into, here is 2 second at time t equal to 2 second they have mentioned here. From this one, v which will be equal to 2 into a. If a is less than over here, so what I'm going to mention here is, so say for example, if a equal to 0 here is, a equal to not 0, a equal to g. In this case what I mentioned here is, this will be equal to g here. But if the velocity is up if the velocity when it approaches towards this magnet, what is going to happen, that will be goes on decreases. So velocity is decreases, so it will be less than 2g. So this is one concept. If you are having v is less than 2g means you can utilize here. So this is not 2g, and even this one also is not there. So here is v, it should be yeah, see here, this one you can utilize here. See, v is less than 2g means here is 4g here. At 2 seconds you can mention as 2a. So 2 into 2 you can mention this one, this is 2 into here if you mention as 2a here. So what you are going to have here is v is less than 4 4a, and even a will be equal to g here. So this will be the answer. Next one, we just think about the distance over here. From this one, s equal to ut plus ut plus of at square. Initial velocity is 0 here, so that what you are going to have 2 into a, I just mentioned as g here, and t here is 2 seconds, that is 4. You just cancel over here. So what you are going to have here is 2g. So s is equal to 2g, and even you can mention this one s, which is if a which is greater than less than g here is s also will be less than 2g. If it is like this 2g, or even a 2 seconds, if you mention this one, if you mention this one, we have cancelled over here. So s will be less than 2g, or even s will be less than 4g. If it is there, we can mention this one. So this answer also will be not there. The only answer in this case, this one here is the magnetic flux, that is pi value they have given 500 microweber per turn, and passing through a 200 turn coil. See, this is magnetic flux per turn. This is 200 turn of the coil. N value they have given, and is reversed in 20 millisecond. This one 20, which will be reversed. So t value they have given. What they are asking here is average EMF induced in the coil in volt. Now this one, and this is the formula here for this one to measure the average EMF. This one I just mentioned as according to Lenz law. Hope you know this one, E equal to minus d pi by dt. But in this case, this is about average. Average in this case, one time, that is n pi by t here. So here already the current is going to reverse. So that reverse direction in this case I just mentioned as 2 here, 2 times. One time, see here, this is about a 200 number of turns of the coil. Here current direction will be along this direction, right? Next one, which will be reversed in this case, so that I just mentioned here. This time what is going to happen here is, this time, see this one, it will be moving like this. So 2 times it is going to happen, so that you are going to have 2 times of magnetic flux induced EMF over here. See, for this one I just mentioned this one, 2 into number of turns they have given, that is 200 here, 200 turns here, and pi magnetic flux what they have given, that is 500 microweber. Micro means 10 power minus 6 is there, and even a time what they have given here is 20 milliseconds. So 20 into 10 power minus 3. Now you just cancel this one for this one for 10 times over here. Say, from this one, this cipher and this one, 3 cipher will be cancelled here. See, from this one, 2 into 5, that is 10 power minus 3 is there, and even this one also will be cancelled here. So what you are going to have here is this one here is 10 power minus 2, and this one from here already you are having divided by 1. 10 power minus 3 also is there. So 10 power minus 3, 10 power minus 3 will be cancelled. So what you are going to have here is 10 volt is the induced EMF. So answer in this case, problem here is the magnetic field B value they are given 2 into 10 power minus 2 Tesla acts at an angle to acts at an right angles to a coil of area they have given 100 centimeter square. This one we have to convert this one meter square, that is 10 power minus 4, with the turns n value they have given. Then if the average EMF induced in the coil, so EMF value they have given zero point 0.1 volt when it is removed from the field in time t. So the value of t here is, see here, at a particular time once the magnetic field has been removed, the induced EMF here is 0.1 volt. See, from this one, what they are asking here is what is that value of T at that particular time you are getting an EMF. So E is equal to this one. They have given a B value here, and this one area I just mentioned as A here, and number of terms I just mentioned as here. See, this one according to Lenz law, E is equal to d pi by dt here, and actually minus will be there because this negative sign which is opposes the change, that is that meaning here, and pi here is nba, and cos here is this one cos theta won't be there because they haven't mentioned this magnetic field which is perpendicular like that. So here they have mentioned the field that acts right angles to that area. So this one and this one only. Say from this one, I just mentioned as T here. From here, E value what they have given here is 0.1 volt, and number of turns here is 50 here, and the B value what they have given here is 2 into 10 power minus 2, and the area here is 100 centimeter square. I just mentioned here 10 power minus 4 whole divided by T here. See, from this one, see this one you just cancel this one, this 2 here, and 15 to 2, that is 100 into 10 power minus 4, and this one I just mentioned here T, and this one will come over here, that is 0.1. So you can mention here 10 power minus 2 is there, this one 0.1 you can mention like 1 divided by 10. So again you can mention here 10 power minus 1. So from here what you are going to have here is 10 power minus 1 here is 0.1 t equal to 0.1 second. So answer in this case, problem, the current decay from 5 ampere to 2 ampere in a zero point 0.1 second in a coil. In one coil, current has been changes from 5 ampere to 2 ampere. The EMF induced in a coil nearby it here is 30 volt. Calculate the mutual induction. So they are asking about the mutual induction. See, for understanding, I roughly draw the diagram over here. See, there are one coil, and there is another one more coil. When a current passing through the coil I just mentioned here, when a current passing through one coil, see this is coil number 1, this is coil number 2. When a current passing through this coil has been changes, this changing magnetic flux is linked to the secondary coil, and this will induce the current in the secondary coil. This works in the principle we call it as a mutual induction. This is the main uses that can be used in case of transformer. Right. Now, this one I just mentioned here. According to this, induced EMF in the secondary coil here is equal to di by dt. Now, this is proportional to di by dt here, or even E is equal to m into di by dt. For a maximum changes you can mention here, that is m into del I by delta t here. Now this one where m is called as mutual induction, this m only they are asking here. First we'll substitute the value here, and changing EMF is 30 volt, and mutual induction that we are going to find out here, and the changing current here is 5 ampere to 2 ampere, that is 3 ampere is the changing current, and the time, what is the changing the time here is 0.01 second. From this one, mutual induction here is 30 into 0.01 and divided by 3 ampere of current. You just cancel this one, this is for 10 times here. See, from this one, mutual induction here is 0.1. So mutual induction or even inductance of the coil, we can mention this one, the unit is in Henry. So answer in this case, this is little important. See, when a current changes from 2 ampere to minus 2 ampere in 0.05 second, and EMF of 8 volt is induced in a coil. The coefficient of self-induction of the coil. Self-induction in this case, the EMF induced in the same coil when there is a change in the current. So the changing the current, change of current they have given here. See, you can see this one, my plus 2 ampere to minus 2 ampere in a time they have given, that is 0.05 seconds, and EMF induced in the same coil 8 volts. So they are asking about self-induction. See, when a current passing through one coil, EMF is changes in the secondary coil, that is we call it as mutual induction. If the current power changes in one coil, EMF induced in the same coil, that we call it as a self-induction. Self-induction we can mention as L. The same one you can mention here, E is equal to minus di by dt here. Now this is proportional over here. So it's the same concept, E is equal to minus L into di by dt. Even you can mention this one minus L into delta I divided by delta t here. So this is a concept. According to this E value what they have given here is 8 volt into, and mutual inductions, that one only we are going to find, minus L into changing current here is 2 ampere to, so see here 2 ampere to minus 2 ampere. So final minus initial, this one 2 minus 2 minus 2 here, and the changing time here is 0.05 second. Say from this one L what you are going to have here is 8 into minus 4 into minus L, 4L divided by 0.05. This one you can cancel here 2 times. So from this one L equal to 0.05 into 2 here. So what you are going to have here is 0.0 no, 0.5 into 2 here is only 1. So answer in this case, see I just mentioned this one, 0.05 into 1. So you can mention here 0.1 Henry. So answer in this case. Next problem. So this one again the same, but the easiest one. But a small trick is that we just go through. A magnetic flux linked with the coil in Weber is given in the equation form. The induced EMF in the coil in the fourth second. Say remember here, I just stressed over here fourth second. Now induced EMF in the fourth second. First remember here, when time in between, see here, when time between, I just mentioned this one, time between 0 to 1 second, here again 1 to 2, and 2 to 3, and 3 to 4. Now this is first second, second second, third second, third first, and this one is fourth second. Now what they are asking here is induced EMF on fourth second. This one they are asking here, right? First one, in this case induced EMF, that means E is equal to d pi by dt. Now from this one they have given here d by dt of, apply the equation, 5t square plus 3t plus 60. Now differentiate it, what you are getting here is 10t plus 3. Now this is about induced EMF, right? This is about the equation. So on fourth second, that's what they are asking here. Fourth second, in this case, in between t equal to 3 second and t equal to 4 second, in between these two. For this I just mentioned here E3, here is 10 into 3 plus 3, here what you are having here is 33, and next one 33 volt, right? And E is equal to fourth second, that is E4, I just mentioned here 10 into 4 plus 3, what you are having here is 43 volt. So from this one, so here is induced EMF on fourth second, just mention a fourth second, here is E4 minus E3, that is final minus initial. So 43 minus 33 volt here. So what you are having here is 10 volt. So answer in this case, this one they have asked in the previous question. So all the things that I have mentioned over here, these and all are previous old question paper problem. See, a rectangular coil of 20 turns. So n value they have given, area of cross section they have given, and as a resistance. See, additional what they have given here is resistance 100 ohm. if the magnetic field which is perpendicular to the plane of the coil changes at the rate of, so here is Tesla per second, 1000 Tesla. So even dB by dt they have given, the current in the coil is. Now usually you can mention this one according to Ohm's law. See, Ohm's law I just mentioned here. According to Ohm's law, here V is equal to I into R. Now from this one I is equal to V divided by R. Here in this case potential V and induced EMF E both are same here, and even induced EMF E you can mention like a BAN. Hope you remember this one, BAN formula here. That one here is d pi by dt here. So this one pi, instead of pi you can mention here d by dt of B, A and N here. Now from this one you can mention E is equal to, what you are getting here is A, N is there, and dB by dt is there. Now instead of B you can mention as E here. From this one I is equal to, so I just mention as 1 divided by R into, here is N A dB by dt. Now all the values they have given. From this one I just write on here, n number of turns here is 20 turns, and area here is 25 centimeter square, that is 10 power minus 2 square, 10 power minus 4 here, and dB by dt they have given, that is 1000 Tesla per second, and the resistance how much they have given here is 100 ohm. See, that's all. Now you just substitute this value here. So what you are getting here is, see, 25 into 2 here is 50 is there, and even 10 you multiply here, 500 into 10 power minus 4. So you can mention this one, uh, 500 here is 5 into 10 power minus 2 is there, or even you can mention here from this one, yeah, this one here is sorry, I'm sorry, this one 10 power minus 4, this 10 and this 10, this is 5000. Now from here 50 into 10 power minus 2, or 5 into 10 power minus 1, or 0.5, that's all. So current in this case 0.5 ampere. So answer here is, into the next problem. This one also quite interesting. First, we are going to make a formula with some of the concepts what they have given. It will be little interesting. Once you are getting this idea, it will be, you may show more interest on physics. You just look at the problem here. A coil of 40 ohm resistance they have given, and has 100 turns. See here, resistance has 100 turns, coil resistance with 100 turns, and radius here is 6 millimeter. Is connected to an ammeter. See here, connected to an ammeter. So this resistance and this resistance, ammeter in this case, both the resistance are connected in series with the resistance of 160 ohm. So coil is placed perpendicular to the magnetic field. When coil is taken out from the field, so 32 microcoulomb of charges flow through it. So the uh, magnetic induction field strength is, so that's what they are asking here. So B value they are asking. See, once you are going to see here, where once you are going to remove the coil is out from the field, so there will be a flow of charge. 32 microcoulomb uh, has been flow into the coil. See, for this case, see here, according to this one, what you are going to mention here is induced EMF. See, I just mentioned as E is equal to d pi divided by dt here, and this one from here, pi value here is, see this one, d by dt of pi, instead of pi I just mentioned here n b into a. Now from this one you can mention here, so n and a is not going to change here, magnetic field is going to change. You can mention this one dB by dt according to that Ohm's law. See here, V is equal to I into R, and V is about potential here, so I just mentioned here I into R. Here I current is nothing but change in charge, that is dq divided by dt into r, that one will be equal to n a into dv divided by dt. From this one, what you can mention here is, say from this one dt will be cancelled here. So what they are asking in this one, changing magnetic flux. So dB is equal to, what are the things you are having here is charge dq r and divided by n into e. See from this one, if you are going to find out the total charges over here, so d is equal to q. Just integrate on either side, dB will become B here, dq will become q, q into r divided by n into E. Now I just substitute all the values here. From charge, how many charges over there? That is 32 microcoulomb, that is 10 power minus 6. And the resistance here is coil resistance 40 and even ammeter resistance, that is 160. Both are connected in series, so you can mention over like this. From this one, number of turns here is 100 turns, and area here is pi r square. Now you just substitute the value here. See from this one, b is equal to 32 into 10 power minus 6 and into 200 here, and whole divided by 100 is there and pi is there, into r square, r value 6 millimeter, that is 6 square into 10 power minus 3 square, that is 10 power minus 6. See from this one, what are the common terms? First you just cancel over here. Say 10 power minus 6 and this one, see here 10 power minus 6, 10 power minus 6 will be cancelled here. This will be cancelled for 2 times. So here is, I just mentioned here, 64 divided by 36 into 3.14. Now approximately 3 you just mentioned here. So 64 divided by 3, if you mention this one, 108 will be there. Now you just cancel these two. So what you are going to have here is, this will become, see approximately, say this is 60 times and this is 110, you just consider as 120, means that will become approximately zero point 0.5. So 60 by 120 you just consider like this. So approximation here is zero point 0.5. So answer in this case 0.56 Tesla. Coming to the end of today's session on electromagnetic induction, where we have gone through the problems on electromagnetic induction. I hope this solution help you to understand the key concept and problem solving techniques that you will need for your examination. If you found this video is useful, don't forget to like, share and leave your comments with any questions. Make sure to subscribe and hit the bell icons for more problems, tips and tricks, and even for your update. Good luck with your studies and see you in the next video. Thank you all for your patience listening. Thank you.